Okay, now we are in the last part of the book called Changing the World. Where am I? Where am I? Where am I? Okay, here we are. Sorry, didn't open it beforehand. But anyway, so part 3 and the last section is Changing the World, and then the last lecture or last chapter will be on concluding remarks of all the chapters we have looked at on sustainability, and we call it sustainability science and change. So this is Changing the World, so you should understand how science works and how change works. In climate science, just to pontificate a little bit, many people keep saying that we should do policy relevant science. Well, that's a good idea, but I would say that we should just work on solutions, because thinking that science gets used in policies or decisions sometimes overestimates the role of science in decisions or underestimates the practical limitations of including science in making decisions. Right now, Biden is struggling, US president is struggling with delaying climate decisions. People are struggling with EVs because hybrids actually turn out to be better in a life cycle analysis kind of sense. And elections will always come and slow things down or accelerate things depending on what looks likely to get more voters. And this is how life works, because politicians have to win elections and make decisions and be responsible, whereas scientists have to just give advice and not really be held accountable for anything. So we have to be careful with that. This is a relatively short chapter, so I will read most of it. Actually, lots of good stuff, so we will discuss pretty much everything in the chapters for the next 3 chapters. Well, the first part of this book focuses on describing the state of the world, and the second part on constructing a conceptual foundation for approaching the world. It's now time to focus on changing the world. I suggest in chapter 2 that science has been central for the development of the world for centuries, and that the rate of change has been closely connected to the speed of scientific development, especially since the period before the Industrial Revolution. So science obviously has been critical for development and growth of society and economies, because all the inventions get used to make money, to build things, whether it's defense or irrigation systems, energy grids and vehicles, roads, infrastructures, buildings, and so on. So that's not what we are talking about when we say policy relevant science. It's about once they build things, how are they managed for staying on the path to sustainable development with the human development and environmental footprint in mind. We haven't been very good at it, and that's how we have ended up here discussing this. If we did it right, then we wouldn't be discussing much about sustainability anyways, right? So keeping that in mind, this period is often, post-industrial revolution is often referred to as the scientific revolution, and involved the emergence of modern science and accumulating developments in mathematics, physics, chemistry, and biology overthrew previous world views. It misses the social science as well: resilience, risk, justice, equity, environmental justice, climate justice, and so on. The speed of scientific developments has continued to accelerate since then, and so has the development of the world in general. It is therefore a great paradox that science has not only assisted humankind to overcome fundamental sustainability challenges in the past, but also created new ones that we now have to resolve. As I said, I'll keep reading a lot of text. Although it is a driving force behind much groundbreaking research, science is not only about satisfying curiosity. There is blue sky research everywhere, and it's always a question of who funds it, how much funding should go in blue sky research, because research doesn't always pay off immediately. There are many things the research was done first and then decades later it materialized into something that became widespread in common use. So it's about explaining, understanding and improving the world we observe by developing knowledge, informing policy, addressing societal issues, developing technology, etc. So there is informing policy again, which obviously works in the sense there is always a advising committee or board or group or so on set up by all governments to seek advice on everything, right, including environmental policies. The remarkable Thomas Huxley once wrote, "The great end of life is not knowledge but action." So we have to then convert all our science into action, and I think he's right. As the author of this book says, knowledge is fundamental but only useful if it can be organized into action to address challenges, which is now the sustainability challenge. However, I'm not saying that all scientific endeavors should be applied to particular challenges, since more fundamental science is needed to provide knowledge to assist us in these applied endeavors, as well as in addressing a whole range of challenges that we may not know we have yet. We also have to be careful, because many times what we see as action based on science have unintended consequences, like industrial revolution bringing more and more energy intensive lifestyles and fossil fuel consumption, leading to all the global warming problems and sustainability challenges we have now, because our consumption rates also grew, and the way we build things to be disposable so that we can keep on buying new things is excellent for economic growth, but it's converting all the natural resources in irreversibly into sometimes unrecyclable junk, which we are trying to now reverse, right? What I do claim is that scientific development is intrinsically linked to the development of the world, but that we have to be aware of the Hume's guillotine presented in chapter 5 that we looked at in when we were discussing chapter 5. In other words, it's fundamental to remember the difference between descriptive statements about how something is and prescriptive statements about how it ought to be, and inferring the latter directly from the former is simply not scientific. So it's one thing to say how something is actually. Remember, our construction of things depends on who actually is looking at how something is. We talked about the example of the rolling hills, farmer, real estate developer, a hunter looking at it and coming up with different description of statements about how the rolling hills are, and then prescriptive statements about how the rolling hills should be or ought to be, take us in a very different direction, because then you got to get all three of them on the same page, right? So this chapter provides a foundation for linking science and change by suggesting a way to bridge the divide between the descriptive and the prescriptive while maintaining scientific rigor throughout the process. To do so, this chapter elaborates on two forms of science introduced in chapter 5, traditional science and design science, teleological versus just observing what is the role of the hill, does it have a purpose, on their purposes and limitations, as well as on the way they complement each other. Is the purpose and limitation related to each other? I then go into details about their respective processes, present different scientific principles needed to assess scientific rigor, and end the chapter by discussing key limitations of science for change. We are talking about science and change, but ultimately we're thinking about whether science is for change, right? So let me leave this here, maybe a bit short, but that's okay, 9 minutes, but we'll come back and move into the next section, continuing our discussion and start talking about science of the complemental, and we'll see what the author means by that. But you understand that science seems to be almost an innate ability, as a part of our evolution, the curiosity, the building, the expertise we have with opposable thumbs. We have gone from stone tools to building, fancier things to hunt and gather, and then we have gone into the Copper Age, Bronze Age, Iron Age, and so on to the modern age industrial revolution, and we seem to be exponentially inventing things. Now we keep discussing AI and whether AI will go out of control, and AI is now in our daily life, but AI itself is now one of the largest hogs of water. Cryptocurrency, which is all the rage now in terms of making money, is consuming more power than many countries. So everything we do has a consequence in terms of environmental footprint. And if we keep coming back to sustainability, then it's again about Human Development Index and environmental footprints giving us the floor and the boundaries so that we can equitably and just ways we can equitably in a just way approach sustainable development despite the detours due to risks we are creating often ourselves. Okay.